Okay, these are the notes on 9-6 in case you missed them from class today. To start, we're just going to review scientific notation, talk about it a little bit. Scientific notation is used to express extremely small or extremely large numbers. So just as a reminder, I wanted this a different color. 8.49 times 10 to the 6th means 8.49 times 10 times 10 times 10, 6 times. Every time you multiply something by 10, you're making it bigger. And so we're moving the decimal to the right 6 times because that's how many times we're multiplying by 10. So when you move the decimal from right here, 8.49, and you move it 6 times, you're going to end up with 8,490,000. So these two mean the same thing, they're just expressed differently. Down here, I have 6.291 times 10 to the negative 4th. Now, 10 to the negative power is repeated division, where positive exponents mean multiply it by this 6 times, negative exponents mean divide it by 10 4 times. So it would be like multiplying by 1 over 10 4 times. And dividing by 10 makes this get smaller. So I'm going to take my decimal right here at 6.291 and I'm going to move it 4 decimal places to the left. I'm getting it smaller. So you get 0.0006291. When we get down here, now we're doing the opposite. We're going to take them and transfer them to scientific notation. In order to be in scientific notation, this coefficient right here must be greater than or equal to 1, so 1 or higher, and it must be less than 10. So the decimal right now is right here. And I'm going to move that over until I get a number between 1 and less than 10. So I get 3.741 times. Now this was a really big number, so it's going to be 10 to a positive exponent. How many times did I have to move it? 1, 2, 3, 4, 5, so 10 to the 5th. Again, these two numbers mean the same thing, I'm just expressing them differently. In this one, is it really big or really small? It's really small. So I'm going to move the decimal place until I have a number that is between 1 and 10. It could be 1. I get 2.9 times 10. Now, this was a really small number, so I'm going to have a negative exponent, and I moved it 1, 2, 3 places, so it's times 10 to the negative 3rd. Over here, 34 billion. That's really big. If you look at page, I believe it's 398 in your textbook, it'll talk to you about billion, million, all those, and the different exponents on them. So I'm going to get 3.4, and then this will be 10 to the 10th power. Now we're going to go over to doing operations, which is the main idea of what we're doing. That material before should have been review, I hope. Okay. The multiplication here, this isn't FOIL, or not FOIL I should say, the area model or distributive model, because there's no addition or subtraction here. Since it's multiplication, I can just rewrite it without the parentheses. And then all I'm going to do is use the commutative property to rewrite them in so the like numbers are together. Now, 8 times 5 I know is 40. And I can use my exponent rules. I have 6 tens in a row with 3 tens in a row, so I have 10 to the 9th, or adding the exponents. Now, this is not in scientific notation because the 40 is not between 1 and 10. So I'm going to move that, turn this into 4 times 10 to the 10th power. The way I figured that out is right here, if I were to go to expanded form, if I went here, let me go to the pen, and I went to expanded for 40 times 10 to the 9th, I would go 9 places to the right. Well, now I'm moving the decimal here. So now how far do I have to travel? Well, I have to travel these 9 plus 1 more. That's what gave me the 4 times 10 to the 10th. Over here in this example, you're going to do the 6 divided by 2. That's going to give you the 3 times the x and the dot. It's the same thing. And I'm going to subtract the exponent, so I get 3 times 10 to the 4th. So push pause, try to work through the remainder of these, and then come back. Okay, for this one, when you multiply the numbers, you'll get 15.5 times 10. Negative 3 plus 5 is 2, so that gives you 10 squared. Not in scientific notation because 15 is greater than 10, so that doesn't work. So I'm 1.55 times 10, and that's going to be to the 3rd power. Over here, I have 6.8 times 2, which will give me 13.6. I'm going to add the exponents together. That'll give me my negative 12. Then, again, it's not in scientific notation, so I have to do that. That'll give me 1.36 times 10. This will be to the negative 11th. If you're not sure how that works, just come and talk to me. I'll show you how that works. And down here for the last one, I'm going to divide the 5.6 by the 7. That's 0.8. I'm going to subtract the exponent. So negative 6 minus a negative 4 is a negative 2. And then here I'm going to have 8 times 10 to the negative 3. So that's my final answer. And again, if you're confused with this last part of how I'm converting it to scientific notation, just ask me and I'll be happy to show you. Okay, in this one, well, first let me go over here. And if I gave you a problem like 2x to the 3rd squared, almost all of you could do that. I've seen from your quizzes. And you would say, well, Mrs. Rumphy, that gives you 4x to the 6th. The same idea is going to happen here. Blue. All right. So I'm going to have 2. I'm going to square the 2, just like I did over here. I'm going to multiply that by, and I'm going to square the 10 cubed also. So that gives me 4 times 10 to the 6th power using my exponent rules of multiplying. Now try this one and then you can come back. Okay, this will give me 3 to the 3rd times 10 to the negative 8. I'm cubing that one too. So that'll give me 27 times 10 to the negative 24, multiplying the exponents. That's not in scientific notation, so I'm going to do a little bit more. And that's going to become 10 to the negative 23, will be your final answer. And that concludes the 9-6 notes.